Hello, my peeps, and welcome to another Power Packed Phillips podcast. Your MSAs for today.
What?
Can you believe it? I can actually sit at my kitchen table. Nice. Sawyer has sold 988 boxes. 12 more boxes to go until she hits the 1,000 mark. Yeah, buddy. If you'd like a box, they're going quick. Let me know. Only $3.50 per box. Alright, today's notes are on lesson 9.1, adding and subtracting polynomials. 9.1, adding and subtracting polynomials. Make sure you pay close attention during this podcast so you don't do this on the EOC. Watch the goalie.
Comes out, he looks ahead, realizes in a split second he's caught in between. Do I put my hands up? If I do and I touch with my hands, it's going to be an automatic red. I'm going to be sent out. He tucks him back in and essentially allows the goal from Jackson to stay.
Epic fail. Alright, if you would write down in your spiral, a monomial is an algebraic expression that contains only one term. So a monomial is an expression that contains only one term. A monomial should not have a negative exponent. So let's look at some examples, and we'll look at some non-examples. Okay, this is a monomial. It is one term, 3xy squared. That is a monomial. These are some non-examples of monomials. Here's your first non-example, 5 plus x. A monomial is not a sum. So a monomial is not a sum. Sum is the addition sign. This is not a monomial because a monomial cannot have a variable in the denominator. No variable in the denominator. This is not a monomial because it has a variable as an exponent. Cannot have a variable as an exponent. And I think our last non-example, this is not a monomial. This is not a monomial because it has a negative exponent. It has to have a positive exponent to be a monomial. Alrighty, let's look at some binomials and trinomials. A binomial has two terms. Binomial has two terms. So that is a term and that is a term. Binomial, two terms. A trinomial has three terms. Trinomial has three terms. This is our first term, second term, and third term, trinomial. So here's an easy way you can remember the name. Think cycles. A monocycle, one wheel. Monomial, one term. A bicycle, two wheels. Binomial, two terms. Tricycle, three wheels. Trinomial, three terms. Alright, so we talked about monomials, binomials, and trinomials. Now let's talk about a polynomial.
Wow!
Polynomial comes from poly, meaning many, and nomial, meaning term. So a polynomial basically means many terms. So check it out. We have a polynomial here. We have many terms. We write polynomials with the exponents decreasing from left to right. So I have an exponent of 3 here, an exponent of 2. I have an invisible exponent of 1. And notice on my constant, nice vocabulary, Blackhawks, I do not have an exponent here. So we write polynomials with the exponents decreasing from left to right. So let's practice one. If you're asked to rewrite this polynomial, we do it so the exponents decrease from left to right. So if I zoom in, you should be able to see this has an exponent of 3, this has an exponent of 1, and there is no exponent here. So when I write them in order, this is my largest exponent, 3. So I have negative x to the third. This is an invisible exponent of 1. And I write my constant at the end, no exponent. Sometimes they're going to ask you to add polynomials. So I have many terms here, polynomials. So if I'm asked to add or find the sum, this is what I'm going to do. First thing I'm going to do is copy down the problem, so please take a moment to write parentheses 2x cubed minus 5x squared plus x, or we can go ahead and put in our invisible coefficient of 1 there, which would be 1x. Sorry, Walker was coming. Plus parentheses 2x squared plus, again, I can put in that invisible coefficient of 1 plus 1x cubed minus 1. So I think this is the easiest thing to do. Let's go ahead and combine like terms. Combine like terms. So when I'm doing these problems, I'm looking for exponents that are the same. So I have an exponent of 3 here and an exponent of 3. So I'm just going to draw a square underneath both of my exponents of 3. Now here I have an exponent of 2 and an exponent of 2, so I'm going to give both of them a blue triangle. This is an exponent of 1. Notice I don't have another exponent of 1, so I'm just going to give this x all by itself a heart. And this is my constant, my number by itself. I do not have another number by itself. I'm going to give that a star. So now I'm going to combine like terms. So I'm going to put my 2x cubed and my 1x cubed together. When I add those, that's going to give me 3x cubed. I've used this, I've used that. Now I'm going to combine my x's that have an exponent of 2. So I have a negative 5x squared right here, and I have positive 2x squared right here. Negative 5 and a positive 2 is going to give me negative 3x. My exponent is 2. I've used that one, I've used that one. I don't have any other hearts to combine, so I'm just going to put a plus x If you want to put to the first power, you can. And I have a -1, so I'm going to put my -1. Now remember, we write these in order from largest exponent to no exponent. So if I'm writing them in order from largest exponent to no exponent, my largest exponent would be to the third power right here. Then I have to the second power right here. And I have an exponent of 1, that's imaginary right there. And then I have my term, my constant, that does not have an exponent. So there is my solution, or my answer. Remember, we're just combining like terms. After you combine the like terms, put your answers in order in your polynomial. Nice vocab. Blackhawks. From the largest exponent down to either the smallest exponent or no exponent. Thanks for watching, guys.